Okay, so in the event that you have to watch this video at home, this is on acceleration. Today is 2/6/25, and so we're going to look at acceleration now. Acceleration is describing the rate at which velocity changes. You might recall that when we were talking about forces, we said, well, the bigger or the more rapid the change in motion, the bigger the force was. This is describing how quickly motion changes. It has to do with acceleration. Now, that was my first car, at least a very similar kind of car. That's a Dodge Omni. I was 16 years old. I bought my first car from my neighbor. It was green, by the way. It had that much rust, but it didn't have a picture. We didn't have phones and all that kind of stuff at the time to be able to take pictures. So I found that one on the internet. It was like, that's a pretty close resemblance of the car that I bought. It was a 1979. It was 1979 Dodge Omni, green. My neighbor knew that I was interested in buying a car, and he goes, Mr. Heisinger, I don't know why he called me Mr. Heisinger. I'm like 16 years old. He goes, Mr. Heisinger, you should buy my car. He goes, it can go 0 to 60. And I was pretty naive. I'm like, wow, 0 to 60, that's awesome. So what should I have asked him when he said it could go 0 to 60? He told me how fast. He said it could go 60. What should I have asked him? How long it takes, right? So what I missed out on is he said it can go 0 to 60, and I'm like, oh, that's pretty cool, 0 to 60. So I get into the car, I pay him $500, $20 each. That was what, 10, 25, $20 bills. And I gave him that, and I put the stick shift, by the way. Raise your hand, you're not driving stick shift? Okay, a few people. So I'm like, I learned how to do this out of the cottage property with my grandpa and stuff like that, so I'm going to do this. 0 to 60, it took me how long? 12, that'd be great. No. That'd even be good. No, it took 20 seconds for it to go 0 to 60. High performance vehicle? No, 0 to 60 in 20. So I was pretty naive. Acceleration is talking about how quickly velocity changes. It is a change of velocity per amount of time. So I want to talk a little bit about let me write it as an equation with letters. I'm going to put this down as an average acceleration, is change in velocity over time. Now I'm going to use some shorthand notation here. The delta in that symbol, the delta looks like a triangle. We say that's delta. The average acceleration is the change in velocity divided by the time during which that change occurred. Let's take a look at units for a minute. That car could go 0 to 60, but it took 20 seconds. So it ended at 60 miles per hour. It started at 0 miles per hour, and it took 20 seconds. Now, I don't need a calculator to do 60 minus 0. That's 60. I might not even need a calculator to do 60 divided by 20. I think some of you can do that in your head. What is that number, 60 divided by 20? It's 3. The tricky part is to look at the units of it. So I know that the average acceleration was about 3. And what I would like to ask you is, what would those units be to be able to describe that change, the rate at which the velocity was changing? What would be the units here based on what you see there? Anyone want to hazard a guess on it? Say it again. Go.
No, I don't know. I just
It's okay. I mean, hey, we're trying to build relationships here, so it's okay. Was it
like miles an hour per second?
Okay, that's exactly what it is. Let's write that. Don't have to. Just be proud. 3 miles per hour per second. Now, I wanna write that down to help you understand what the heck that means. The units for acceleration are pretty tricky. It's talking about how quickly motion is changing. Well, motion involves a rate, miles per hour. And then we're saying how quickly that changes. So technically, this is what's called a rate of a rate. Miles per hour per second. Now, I want you to throw me Jesse, could you throw me a meter stick? Not literally throw it. Here's the speedometer. Is this the right direction for the speedometer for you guys? The speedometer needle. If you're driving that way and you're looking, is that the 0 for you guys, or is it here? Which way is 0? This way? Okay. 0. I step on the gas of the car. This is the speedometer needle. This is what it's doing. Its acceleration is describing how quickly that thing is speeding up. Would you guys agree that that needle is moving upwards, so I'm going faster, but the rate at which I'm going faster is not very high? It took a full 20 seconds to get up to 60. Now, it's a stick shift, so it really is one of these. Right? Because it wasn't a constant acceleration, but it took 20 seconds to get there. So it's a very slow acceleration. Oh, by the way, it's downhill with the tail end, right? So, I mean, it wasn't a really, really powerful engine. Raise your hand, you have a job. Would you mind sharing what you make? Yes.
An hour?
Yeah.
60 bucks an hour.
How much?
16.
16 bucks an hour. I'm going to give you a raise. We're going to make it 20. Okay? So $20 an hour. I'm going to do something with you to see if you can understand this concept of rate over rate. Where do you work?
I work over at Mincy.
That's it. We'll make it. Right. So you're making 20 bucks an hour. Starting pay. Every 3 months, because there's training involved, every 3 months they're going to give you a raise. Every 3 months. They're going to give you 50 cents per hour additional every 3 months. Okay? So after 3 months, you'll be making $20.50 per hour. After 6 months, you'll be making $21 per hour. After, you understand the idea? You're getting a periodic raise. Could you turn and tell that person that you're sitting next to, what is the rate at which Jesse's pay rate is changing on an annual basis? Could you do it? Right. See if you can understand the idea of what acceleration is a rate of a rate. What is his pay changing at on a rate of at an annual basis? First, what would be the units of that? Say it again. So it's going to be a rate of a rate, so it's not dollars. By the way, dollars would be equivalent to miles up there, right? It'd be dollars per hour per year. So what would be the rate at which your pay rate is increasing?
What? Sorry.
I know, it's early. And this is one of those really tricky concepts, right? So you make $20 an hour to start with. They're going to give you 50 cents per hour every 3 months, an increase, right? So after a year, do you guys agree after a year you'd be making $22 per hour? After 2 years, how much would you be making? $24 per hour. After 3 years, how much would you be making? What's the rate at which your pay rate is changing? $2 per hour per year. You notice that you're saying this twice, right? You're saying per twice. The tricky part of the acceleration is that there is a per, right? It's 3 meters per second per second. It's 3 miles per hour per second. It's $2 per hour per year. So there are 2 rates there. And that makes it tricky for people to understand. Okay? That's one of the challenging things of acceleration. I want to emphasize that this is the rapidness. I go back to, again, our concept of how force is related to rapid changes in motion. So when I talk about the acceleration of an object, that's tied directly to the amount of force that's acting. The bigger the rapidness of that change in motion, the more force is needed. Okay. Now, there's 3 ways that we can change the velocity of something. One of those is to speed up. There's something in my car that allows me to accelerate by speeding up. What is that thing? Go ahead, you know it. The gas pedal. Okay, so the speed up, that's the gas pedal. There is something in my car that allows me to slow down because I can slow down too. So I can speed up, I can slow down. And you're on a roll here. What's the thing that allows me to slow down? The brake. All right. So these 2 are accelerators in the car. The gas pedal speeds us up, the brake pedal slows us down. There is one more accelerator in the car. What's another way that I can change my velocity? So the transmission is a part of the machinery to allow the rotating, drive shafts to be able to be transmitted into rotation and motion there. That's not what's accelerating my car. I got it. So if I fell off a cliff, I would allow gravity to speed up my car, but that's not. No, there's one more accelerator in my car that people often will forget about. Which one is it? There's another control mechanism in the car that allows you to accelerate. I know the gas pedal speeds me up. I know the brake pedal slows me down. By the way, do you think my car, the 0 to 60 in 20 seconds, do you think it could speed up at a higher rate or slow down at a higher rate? Which one do you think actually is better at changing its motion? You guys agree that brake is probably a better decelerator than the gas pedal? Okay. So I could slow down from 60 to 0 in like 2 seconds. Right? I mean, come to a very quick stop. So a much higher deceleration there. There's one more thing. What is it? There's another accelerator in the car. Where's it called? Here's, or not anymore. Constant speed. 5 miles per hour, 5 miles per hour, 5 miles per hour. Is it accelerating? Is it changing its velocity? Velocity includes the direction. Is it accelerating? Yeah. So even though this is a constant speed, it's not a constant velocity. What is it in my car that allows me to change my direction even if it doesn't change my speed? The steering wheel. The other accelerator is a steering wheel. So we can turn. This is the tricky one. That's the steering wheel. I know that you guys understand the gas pedal to speed you up and the brake pedal to slow you down. The idea about velocity being different than speed is that velocity includes the direction. So if it is changing which way it's moving, it is accelerating. Okay? It's a tricky thing to pull together. Now, acceleration is tied directly to forces. So I'm gonna stop with that. I'm gonna save the math portion stuff. We'll do that stuff with you guys tomorrow. And then we're going to look at free fall acceleration stuff tomorrow. Okay, we're going to put the brakes on a little bit with you guys for content, but we are going to plan on quizzing by Tuesday now. Okay, so one last topic about free fall acceleration. We'll do that stuff. All right, guys, that's all I have. It's about 8:28. A couple minutes to sort of decompress, grab your stuff there. Let's see. I need to make sure that we're actually doing our job here. It looks like we're doing a pretty good job there. So wait a second. Oh, did you move over? Is that what
yeah, that's.
Okay, yeah. Help me with just make sure you get them to the right spot because I will often have to just look up there. So please help me with that.
Oh, yeah.
Yeah, thank you guys.